Good afternoon, Ms. Rahim and Ms. Fatima. In this opportunity, I would like to talk about my capstone project titled Comparing Two-Stage Classification and Genre Incorporated Method for Explicit Lyrics Detection. So we know that there are negative influences through the media exposure, which in this case may include explicit music, which are observed on younger demographic of children. The explicitness may include misogyny and sexual remarks, which commonly found on rap and pop music. Also, we know that the streaming services as such, Spotify and Rhapsody, grow rapidly, and thus this ease the access of this explicit content to the vulnerable children. So based on this, we can make some formulation in the problem statement. Is that the first one? The tedious work of manual filtering of explicit content due to the rapid increase of these type of contents. There are also positive correlation between explicit content exposure and detrimental children behavior. There are also possible relation between additional song data and the lyrics. And lastly, there is also positive association of lyrics and explicit flag in determining the genre of the song. And then, based on this, there is a need in combining additional data, in which, in this case, is going to be the genre, along with lyrics to be used before building machine learning, or maybe the generation of new method in classifying explicit instances. So, the final result of this study is that to enhance the effectiveness of explicit content filtering, improve user experience, and also address this issue of explicit content exposure. So these are the research questions: how to create a comprehensive data set, what is the impact of integrating the genre-specific features on the performance of the machine learning model, and then lastly we will determine whether which of these methods is superior compared to other. So the research objective are as follow. The first one is to create a comprehensive data set by gathering the data from publicly available repository and also additional APIs provided by the streaming services. Then to evaluate the impact of incorporating genre-specific features on the classifier's performance, and lastly to determine and compare the effectiveness of two-stage classification and the incorporation of the genre feature. So the scope of project are as follow. The first one is that it will encompass the development of machine learning model, but it is not possible to explore all the available machine learning model. Then this project will utilize a public data set, and that it may not cover the entire scope of explicit song. And then the project utilize genre-specific feature obtained from the API, and the two-stage classification used in this study integrates machine learning as the initial step, and the second step uses the dictionary-based approach, where the explicit content is assessed further and refined. So the significance of the project is, first one is that is to compare the two new approaches in content detection, then to guide musical artists, streaming platform, as well as regulatory authorities in making policies, and then also to allow music streaming platforms to align music selections with user preferences. So these are the previous words related on the classification of explicitness, and which for some of them, not only they are using lyrics as the dataset feature, they also incorporate some additional data. While the second one, these are the study on the classification of genre, and in addition to the primary variable of lyric, they are also using some other additional data. The project workflow is going to be as follow. The first one, we are going to compile the data set from the available secondary data set as well as data from APIs. Then we are going to do some pre-processing and vectorization, in which essentially it change the unstructured format of lyrics into the numerical metrics. Then lastly, we are going to do some trend and test splitting to train the data in machine learning model, as well as to test the data and to evaluate the performance of this model. This is the project plan. Then for the data preparation, as I mentioned earlier, we are going to compile the data from three sources. The first one is Kaggle.com, in which it comes in CSV format, but before we do another pre-processing. We reformat the name because it didn't follow the right structure, and then after that we're going to filter the language of the lyrics to make sure only English songs are there in the data set. Then we gather the data from Spotify API, in which the first thing that we need to do is to find the song ID. We input the track name or the song name, also the artist name, and from the song ID we can gather the explicit flag. Then lastly, we are going to gather the data as well from the Last.fm API. We will get the text by imputing the track name and artist name, and then from these compiled text we will filter the genre. So these are the codes used in filtering the language. We are going to use a lang detect library and specify the language to be English, and to make sure only English based songs are there in the dataset. Then these are the steps in setting up the Spotify API, in which we are going to input the artist name as well as the track name to get the song ID. We see that the song ID is the unique identifier, the randomized word combination of a letter and also numbers. And then these are the script we use to get the metadata. As the metadata stored in JSON format, we're going to specify it as shown in the figure. These are the script that we use to setting up a Last.fm API. We get the data from Last.fm by inputting the track name as well as the song name as shown here. So we see that actually not all of these data having the text, even for all of them, not all of the text contain the data regarding on the genre. So that's why we're going to filter the genre by using the script. The next step in this project is that to do some data pre-processing. The first one we are going to do, we're going to expand the construction. For example, we are going to change it into IM. If we change it into we have, then continue by removing the punctuation, which is not going to be needed in analysis. We are going to do some tokenization, and then removing the stop words, which are essentially the words that are not going to be really important or having any meanings. Then we're going to do some lemmatization to reduce each of these words into their root form. So for the baseline model, which is the model building phase of this project, we are going to have the clean data, and then from this clean data we are going to transform it into the TF-IDF matrix as shown in the figure. Then because the data is highly imbalanced, we are going to do the smooth algorithm before training the random forest, support vector machine, and knife base. So these are the scripts used in TF-IDF vectorization. We are going to specify the sublinear TF, as well as the script used in model building and dataset balancing by using a smooth algorithm. So for two-stage classification, we are going to have the prediction from machine learning model, in which in the table it is going to be the column Y pred or Y prediction. So we are having a dictionary called Provine words, in which for each of these lyrics we are going to look at each of the term used in the lyrics, whether it contain any of these Provine words. If the lyrics has at least one of word in this Provine word list, we are going to change the prediction into one. So the final prediction, or the prediction that is going to be evaluated, is the Y pred final at the right side of the table. Then the second method in this project is going to be the genre incorporated model. So we have the clean data. Then we are going to split this data into two. The first one is that we are going to do some TF-IDF on the lyrics. Then secondly, we are going to do TF-IDF on the genre. So then we are going to concatenate the matrix before we're doing the dataset balancing and model training. So these are the scripts used in the vectorization of lyrics and genre, as well as to combine both matrices of the FIDF. Okay, how about the model performance? The first one is the two-stage classification. We have the objective to build a robust model less affected by the class imbalance in explicit song detection, in which this method refines the machine learning prediction by comparing every non-explicit predicted lyrics with the dictionary lookup, because the second stage has more discriminative power and it results in higher number of captured true positive. But however, this comes with a low precision, as this method is relatively simplistic and does not account for the context of the nuance on the lyrics. We see that the baseline model, which is the random forest model with lyrics only, it gives quite low recall on non-balanced dataset. However, when we are doing two-stage classification, the recall increases by more than 50%, but however, it comes with much lower precision, meaning that for every predicted instances, we cannot rely on the prediction from the model, obviously. Then, for the genre recommended, we see that each distinct algorithm, which is random forest, support vector machine, and knife base, that are trained or dataset enriched with genre-related feature, have better performance in terms of their F1 score. Thus, this signified finding by Meyer et al. At 2020 that there are correlation between lyrical feature and also the genre. We see that the highest performance model is a random forest model with lyrics enriched with the genre related feature on balanced dataset, followed by the support vector machine, then lastly by multinomial knife base. So from this result, we know that there are semantic relationships between the song and genre. As such, certain explicit themes are commonly found on a specific genre, especially in rap and hip-hop. Frequently used terms listed here suggesting a shared lyrical styles and subject matter between these two genres to the explicit content. So we also look at the performance of the model comparing when it is being trained on imbalanced and balanced data. We know that imbalanced data often leads to biased model that perform well on the majority class, but it perform poorly on the minority class. And based on the analysis, we know that the model trains on oversampled data have higher performance compared to those of imbalance. So what are the practical implications? The first one is that streaming services can significantly improve the accuracy of their explicit content detection through incorporating the genre data. However, obtaining accurate genre data can be challenging. Despite this challenge, however, the trained model that use lyrics alone has proven to be quite effective. And lastly, is crucial to provide the guidelines and policies regarding on the use of this model for both artists and the listeners. So we create some practical usage of this explicit lyric classifier using a stream equation, in which essentially it is only used to demonstrate the capability of random forest classifier on balanced data. So this is the interface of the explicit song analyzer, and I'm going to demonstrate how to use this interface. The first one is that we need to find lyrics of a song, in which in this case I'm going to use an explicit song. I'm going to copy the lyrics into the text box and press the submit. It shows that this song is explicit, but however when I'm using the other one, and then remove the previous one, it shows that this song is not explicit. So what are the conclusions? The first one is that a comprehensive dataset for explicit song classification was constructed by sourcing data from available repositories and APIs. The integration of genre information enhanced the model ability to detect explicit content. Then a two-stage classification is proven to be highly effective in enhancing the recall, but reducing the precision by a lot because it is really simple and fail to account for the context. But however, on the contrary, the genre incorporated model is superior in context where the balanced approach is needed. What are the recommendations? The first one is that it is advisable to employ more sophisticated classification technique, as such neural network that can better capture the integrated relationship between content features. Then we can also utilize the user annotated text, not only the genre-related term, which is maybe limited in its availability. And then it is possible to utilize some NLP techniques like n-gram to help capturing some contextual meaning of phrases and sentences. And then lastly, it may possibly increase the accuracy of explicit content detection. That is all from my capstone project. Thank you for your attention.